Good evening, everyone. Let me ask you a question. Anyone has taken a bus before? Bus or taxi? Yeah? Okay, all right, all right. How many of you have seen a sleepy bus driver or taxi driver? Yeah? Okay. How do you feel? Happy? No, worried. Okay. So that's precisely what we are trying to do. My students, Arsal and I, we want to save life because it's very dangerous to drive while sleepy or not paying attention. So we found that this is a major problem everywhere, not only in Dubai where we live, but also everywhere in the world. A lot of road fatalities because of this. So it's not that big companies like Mercedes, BMW not thinking about this. They already have some solutions for this. However, this is limited only to high-end class cars, vehicles. Also, there are some attempt to make, but it's expensive and it needs a high computing power. So we ask ourselves, can we do a similar solution, but with lower cost? Easy to build, with the component that is available everywhere. So we come up with this idea to make a UDAMS, Universal Driver Alert and Monitoring Systems, that can be fit into any vehicles, including old vehicles like old buses, old taxis, old trucks. So many people will benefit from this. How we did this? Well, first we talk to people. We study different type of vehicles. We study different type of requirements, and then we start doing the prototyping, start gathering the component, analyzing, and then we come up with the design, and then finally we settle with the Raspberry Pi 5 with the infrared camera, and we test it. So the implementation is quite simple. We have an infrared camera and put on the Raspberry Pi. We put it on the dashboard, and then we have also software implemented on it. Yeah, we try with a different height, and we have this formula. This is not by us. This is by Sukupova and Keck. This is from the previous, from what we found in the literature review. So actually, what they did, they have 68 points. To map the face. So for example, like a 1, 2, 3 until 17, and then the eyebrow, the eye, the mouth has all the marking already, but we manipulate the formula. So we only focus on the eyes, so we are able to see how big the eyes is opening, and also the mouth. So we have two parameters over here. The ear is not this ear, but it's the eye aspect ratio. So this is how open our eyes. And then the MAR, which is mouth aspect ratio, is how much our mouth open. This is important because if you yawn, your mouth open. So that means you're sleepy. So we, based on these two things, we predict that, oh, the driver is tired. If you close your eyes more than a few seconds, this will give alert as well. Now the problem is, not everyone has the same eyes. Some people have bigger eyes, some people have smaller eyes. Fortunately, in our university we have more than 130 nationalities, so we have people with different size, color, and shapes. So we are able to test with the different types of people, and that comes to our conclusion that we can do baselining. So before we run this software, we can ask the user, what is the type of your eyes? Is it very small or medium or large? So we can enhance the accuracy of prediction by letting the user to choose. Of course, maybe next time with AI, it can do a self-calibration prediction like this. So we tested this in our lab and as well as on the road. with a different lighting condition on the day, on the night, and the result is quite convincing. We tested with about 35 participants in the lab with a simulator only, so we put the steering wheel, like using a game steering wheel and fake dashboard, and then watching there's a big screen like this showing the road, and let them drive in the lab. Detection accuracy is 92.3%, and it can detect the eyes and mouth. Surprisingly, on the real road, it shows like a bigger percentage, a little bit, maybe because we have less people try it on the real life. So, in conclusion, we have a demonstration after that. I will show you the
So this is the UDAMS mobile application. Now let's create an account and demonstrate how it all works. First, we'll sign up. And I've speeded up this process to save us time. Now as you can see, as soon as I sign up, the change has been made in the Firebase. And we'll select the threshold and we'll set it according to our island size. Now the system has started, and as you can see, it has the selected threshold as well as the EAR and yawn. And as you can see, now I'm demonstrating the drowsiness, and it has been detected and shown on the mobile application. Now we'll go for the yawn. Yawn has been detected as well, and it shows in real-time logs on our mobile application. Now I've added another feature here, where if the user was detected first and then later it went out of frame and is not detected, it waits for 10 seconds and then gives a warning for no phase and asks user to be active and be present. Now let's have a quick look at this all implemented in our Raspberry Pi.
So just to be clear, the mobile app is not a must because the device itself will be able to.
I'll quickly demonstrate here due to our time constraint, but all the features and all the updates are working really well on the Raspberry Pi as well. Thank you.
Okay, so the conclusion, it works well, low cost, less than $200, and it can be implemented in any vehicle. If you don't have any question, we can go for dinner faster. Okay, thank you very much. 谢谢你. It's very clear.
Okay, we have lost our speaker. So